All right, so continuing on with these review problems, we're still on logistic regression here, and we're looking at the probability of surviving breast cancer after 5 years given the size of the tumor. So we're going to use this equation to estimate the log odds, and probability of survival. So let's, for someone who has a tumor with diameter of 3 centimeters. So we'll just plug that right in there and get the log odds. That's 3 minus 0.6 times 3. And so we get 1.2. Then we'll get the odds. That's equal to e to the 1.2, which is 3.32. And then to get the probability, remember probability is just odds over 1 plus odds. So we have 3.32 over 4.32, which is equal to 0.7685. Oh, there's a percent sign here, so 76.85%. So that's our answer. Now, how does the estimated probability of survival change if the tumor increases by 1 centimeter? Does it change by a fixed additive amount? No, it's not a line. Probability, as you recall, is a curve. So it's not going to change by a fixed additive amount. It's not going to change by a fixed multiplicative factor. That's the odds ratio that does that. This is the odds ratio that does this. This is the log odds that changes. It's a line. But the probability, neither of the above. You can't describe how probability changes with either an additive or multiplicative constant, since probability is bounded between 0 and 1. And it has that S-shaped curve. In this case, it's going to have a slant this way because it has a negative slope here. And as you can see, it's very shallow slope here, but very steep in the middle and then shallow again. Okay, so now what diameter does the, so that's the answer. What diameter does the tumor have to have for the estimated probability to be, okay, the probability is 0.2 of survival. How big is the tumor going to be? It's probably, when it's 0.8. 80% is going to have a smaller tumor size, but let's figure this out. All right, so we have the probability, and to get the odds, remember, odds is p over 1 minus p. So we have 0.2 over 0.8, which is equal to 1/4. And then the log, just take the log of that, and you get negative 1.39. Now, we can now solve for the diameter in the log odds equation. So we can say negative 1.39 is equal to 3 minus 0.6 times the diameter. So what's the diameter? The diameter is going to equal 4.39 over 0.6, which is 7.32 centimeters. Now we can do the same thing for an 80% chance of survival, so it's going to be a smaller tumor for sure. And now what do you have? You have p over 1 minus p, so you get the reciprocal here. So the log odds is going to be the opposite sign. And now we can just say 1.39 equals 3 minus 0.6d. So we get d, in this case, equals 2.68. So if you have a smaller tumor, you have a higher chance of survival. Now, below are the plots depicting the probability, the odds, and log odds. The x-axis is the diameter, and the y is either probability, odds, or log odds, which is which. So, right away, you should see that this is the probability here. And this straight line is the log odds. And this is the odds, this exponential curve. All right, so which plot is which? Plot A, probability, C, odds, and B is log odds. Now, the log odds we were given, what are the odds and probability equations? Well, we're given the log odds, so the odds is going to be e to the, we anti-log it, e to the negative 0.6x. And the probability, remember the probability equation, probability is equal to odds over 1 plus odds. So it will be e to the 3 minus 0.6 x, that's the diameter, over 1 plus e to the 3 minus 0.6 x. Now, judging from the plots, what tumor diameter gives a 50-50 chance of surviving 5 years? All right, so you could look on the probability right here at 50-50, and you could see what x, and it looks like 5. But if you couldn't see that, an easier way probably is when you know that when you know that probability is equal to 0.5, that means that the odds is going to be equal to 1-to-1 odds, which is 1, and then the log odds be equal to 0. So it might be easy to read this off of this graph right here, where you see where 0, here's 0.5 for the probability, 0 for the log odds. So that looks like that's 5 right there. And right here, this looks like the hardest one to read. This would be where 1, it's not too bad, intersects at 5. So either any of those will show the answer here is 5 centimeters on the x-axis. All right, the diameter size that gives a 50-50 chance of surviving has a y value in plot B, which is log odds of 0, and here of 1. So I think that's it for that exam. And now why don't we look at the study guide problems.